Next, we're going to cut the rough out this remaining material at the groove over here. And okay, so make sure you select the empty the operation tree, the empty space. And it's not necessary to delete this process. What you need is to select it, highlight it, and then after you load the process, it will be the third one, rough groove. It will automatically override the selected process. And for this groove roughing, we're going to choose another tool. We're going to use a finishing tool actually. This is a cutter. Okay, this tool. After you load the process, the tool, of course, it will automatically load out. We will zoom in the groove area. Select this geometry, cutting at these directions, and starting features we put here, and extend it. Maybe move the start point to maybe 3 mm, and the end features we locate it over here and move the end features also by 3 mm, for example. So after you select the geometry, the next step is to click do it to rough the groove area. Next, we're going to create the finishing operations. Make sure the operation 4 is highlighted, and make sure the process is highlighted. We're going to override this existing process. We're going to load the finish thread operations. Okay, in this case we have a new tool, the threading. We're going to perform the threading operations and the finishing operation together in one operations. This is the finishing setting. We're going to use a default, and the threading settings, we're going to use a default also. Next, we're going to select the geometry to machines. We're going to machine these directions, this arrow. The start features we will locate at these locations, and the end features we will locate at over here. And we're going to extend the start features to 0. We want the tool to cut or to start exactly at the X0, and end will end at 3 mm extensions. After you select the geometry, then just click do it. So you will have a one operation with two processes together, threading and finishing. Next, we're going to simulate all the process, and make sure you right click over here, this icon, and make sure you select the simulations. We're not going to use the flash CPR simulations, and left click on the simulations, and we need to do some settings over here. Right click and select the settings. On the settings, make sure the cut height is 0.1. This is the tolerance of the simulations. If this value is smaller, then the simulation will be slower but more accurate. This is the tolerance for body. And the speed, let's put 20 and 20. Make sure your setting is same as mine, and then click apply. And the last one, we're going to right click again or on the bar here, and select the op color, operation color. Over here you have option to select the cut color or or set the color by 2 number or by operation number. So we're going to use this by op number, by the operation number, and close it. After that, we'll make sure you reduce the speed until the halfway, and then click play. You can see now each operations, the color is different. And the thread is actually in helix mode. Let's go home view. You can see here the actual helix thread. By looking at the simulation closely, the result, you can see this area is in red color. This means that some rapid motion already touch this face over here. Some problems. Close the simulations and now double click the finishing operations. Just click only the finishing operations and click withdraw. You can see now at this side the rapid motion is touching the chamfer face. How to solve these problems? We can let's double click the operation 4 and click the first process, the finishing process. To solve this, we can always put a radius and extension line to lift up the rapid. Put 1 and 1 and click with 2. You can see now the 2 is going by a radius of 1. Let's do the simulation again. And you can see now there's no more red color. The problem is solved. Next, we're going to cut this hex, the y-axis cutting, do some y-axis cutting. Make sure operation 6 is selected. Delete the unwanted process. And we're going to load the y-axis cutting process. This process comes with a cutter, a finish MU diameter 20. To do a y-axis cutting, we need to change our coordinate systems. Click this icon, and we need to change to the YZ coordinate systems. And then we need to change the process. At the back, we need to change the machine's coordinate systems to, this is important, YZ. And we're going to copy 5 times by 6 degrees also, 5 times 6 degrees. Okay. Next, to select the geometry, you can pick and drag this profiler to the location that you want. You can pick and drag. If you want to the profiler at this depth, the hex, same depth as the hex here, the flat face here, you right click the profiler, select the profiler depth, and make sure all this value is highlighted, and make sure you press the alternate key on the keyboard. Then your cursor will change to a box, and you just pick this face, and it will update this value to this box here. Then you just click apply, then the profiler will immediately shift onto this face. Okay. Next, we're going to select this to cut. The cutting direction is okay. And I'm going to start put the starting feature to this and move this out maybe by 3 mm. The end features will end at this features and move the end point out by 3 also. Let's check again the settings. The clearance 80 mm is good. The depth, this is the depth. The depth now is same as this one. Okay, if you don't know what is the depth you're going to cut, let's say I put it 125 now. You can always use the alternate key also. Select alternate key on the screen and click the point over here. It will update the value into the depths over here. So we're going to machine at the 54.991 both. And then select do it. Next, we'll simulate the y-axis cut. Go to the simulations. I'm going to rewind it. And I'm going to set some setting. Right click here. Use set start stop options. And also, we're going to ask the simulator to stop at number 6, operation number 6, and play. Fast forward to operation number 6, and let's zoom it, and let's reduce the speed. And this is the hex cut.